Okay, good morning, LH2 Extended. Second to the last lesson of Chapter 5 here, 5.5, Day 1. Rational root theorem. Pretty important one, kind of confuzzling for a bit, but it's actually, follow along. To-do list this week. Well, obviously we're in the live session, Day 1, 5.5, Day 1 with everybody here. When we're done with the lesson, you're going to complete the try on your own assignment. And just let you know, next Monday there is a test, okay, on Chapter 5. Tomorrow we're going to do Day 2 of 5.5. Lesson's done. You're going to complete your 5.5 Day 2 try on your own assignment. And guess what? Yep, that's right. There's a test on this coming Monday. Wednesday, what we're going to do is we're going to clean up any questions you have on Lesson 5.4 or 5.5, which is tons of factoring. And after we clean those questions up, if you have any, well, then there's a formative that's placed in its learning for you to do. And just want to remind you, did you know that there's a test on Monday? Thursday, live Chapter 5 review for everybody. So if you have any questions, that's the day to get them answered. You're going to be working on your review assignment, hopefully for the whole hour. And if you haven't been told, there's a test on Monday. Okay? And Friday, you'll have work time for what you don't get done. So there's a warm-up here. You're going to want to go all the way to the last page of your notes. There's a little section that's opened up. It says do warm-up here. And I would like you to factor these three polynomials, and we will be back with the answers. Okay? Well, rather than just put the answers out here, what I'm going to do is I'm going to come here to number 1. And what's the factor that we know is in x cubed plus 27? Well, the factor we know in there is the cube root of x is x, plus stays there. Cube root of 27 is 3. That's the factor we know. And if we know the pattern going on here, we know to get the first term in the second set of parentheses is you take the first term in your first parentheses and you square it. The next thing is the sign is always opposite. Then all I do is take each term in that front parenthesis, x and 3, multiply them with a 3x. Next one's a plus. Take the last term and square it. I get 9. There they are. There's your real solutions. There's your imaginary solutions. Number 2, what factor do I know is in here? The factor I know in here is whatever the cube root of 8x cubed is, that would be 2x, minus the cube root of 64, which would be 4. Okay? Then my second set of parentheses is I take that 2x times itself, so 2x times 2x is 4x squared. My sign changes, and then I just take the 2x times the 4. That gives me an 8x in the middle, and then a plus that 4 squared to give me a 16. And what do I notice I could have done here? Ooh, I missed my greatest common factor that I could have taken out right out of the blocks. That doesn't matter. I can still take them out. There's a greatest common factor here. I can take the 2 out of the x minus 4 and have an x minus 2. And I also have times a 4 I can take out of each one of these. That's going to give me an x squared plus an x plus, a 4 there, right? And I can take that 2 times 4 and say that's 8 times x minus 2 times x squared plus x plus 4. Except that should be a 2x. I'm sorry. Little blemish in my mathematics here. That should be a 2x, right? And it should be a 2x because when I take 4 out of 8, I have a 2x left in there, so that 2x is there with a plus 4. Okay? For those of you sharp tacks out there that took your GCF out first, you first went to 8 times and you went to an x cubed minus 8. And then you said, oh, I know that. That's 8. I know the factor in there is x minus 2. And then you took that first one, you squared it, and you got a 2. Change the sign. X times 2 is 2x, plus 2 squared is 4. And you got the same exact thing. You just got there faster. But I just wanted to show, if you miss your GCF right away, it's not the end of the world. You don't have to erase and start over. You can take the 2 out of the first set of parentheses, the 4 out of the second, multiply them together. There was your GCF that we may have potentially missed in the beginning. Okay. Last one I got here is, I'm going to let you do this one on your own, and I'm just going to come back with the answers. Hit pause and finish her up. And you're right back here. The factor you know that's in there is 3x plus 5, because cube root of 27x cubed is, 3x. Cube root of 25 is 5. The sign stays the same. And there we go. That's where we're at. Well, if you're wondering, oh boy, I didn't remember that. When you factor your sums and difference of cubes, if I have a perfect cube plus a perfect cube, the cubed root plus the cubed root of each term. And then what I always do is I take that first term times itself, and that's what goes there. My sign is opposite. Then what I do is I take the first term times the second term. That's what the A times B is. Don't worry if they're positive and negative, just always consider them positive. And then plus the last term squared. And the only difference is if it's a minus, it's A minus B. And then the first term squared, opposite sign, multiply those two terms, plus the last term squared. And there you go. Your real roots are usually in the beginning. Well, they're always in the beginning. Imaginaries are second. And remember, these second ones never factor more. Okay? That's a big thing to know right there, because it saves you from guessing and checking in the end. So what we're going to do here, 5.5, we're talking about the rational root theorem. And bottom line, up until this point, in order to completely factor a polynomial with a degree higher than 2, pretty much if we couldn't factor by grouping, okay, we needed to know one of the factors or one of the roots of it, okay, whether that was given to us or we took it from a graph or a table. And then what we did was we verified that factor through synthetic division in the factor theorem, meaning we got a remainder of 0. So then we could take that factor out, and we just, as the nut job in the video says, took it down a notch. But what if they don't give us a factor or a root? Kind of like what I have right here. F of x equals 2x cubed plus 3x squared minus 5x plus 6. What happens if I can't do that? Because if you look right away, if I try to group these, all right, and I try to factor by grouping, well, yeah, I can take an x squared out of the first one, and that leaves me a 2x plus 3. There's nothing other than a negative 1 to take out of this second set. That gives me a 5x plus 6, okay? And if you checked it out, I can't go any further because I don't have any more common factors to come out. Well, that just doesn't mean we fold up and croak, okay? That just means we need another method of factoring here. So I'm going to edit all this ink out of there. And what the rational root theorem tells us here, okay, it's guessing and checking at its best, states that the rational root of a polynomial equation, blah, 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 blah there, with integer coefficients is of the form p over q, where p is the factor of the constant term, okay, and q is the factor of the lead coefficient. Remember, lead coefficient is simply the number tagged to the biggest power in your equation. So p over q, what this is saying is p divided by q. If my factors are rational, meaning if they're not ugly decimals, if they're a fraction or a whole number, okay, not like the square root of 3, not an irrational number, okay, they will be in the form of a p over q. So what we're going to do is we're going to look at p to factors of p divided by factors of q. Well, p is actually 6, q is 2. So we're going to look at all the factors of 6. Well, that would be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6, divided by factors of 2, that's plus or minus 1, okay, plus or minus 1, plus or minus 2. Those are all the factors I can use. Then from there, I'm going to make a list, okay, all the potential factors that could be zeros of this function, if they are rational, would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All I did was I took the 1 and I wrote it over 1, 2, 3, and 6, okay? And then the second one, okay, so I've done that one. Next one, I'm going to write 1, 2, 3, and 6 all over 2, okay? But I don't want to repeat things, but I'm going to say plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, plus or minus 6 over 2. And I make a fraction, and there's no more left out of my P's and Q's there. So then I'm going to look, but I want to eliminate any repeated factors, because what is 2 over 2 plus or minus 1? Hey, this one is already in my list right there, so there's no reason for me to list it again, if that makes any sense. So I'm going to get rid of that one. And 6 over 2, hey, that's the same as 3, so I'm going to get rid of this guy. Okay? And then I'm going to take, whoa, didn't like that. Then I'm going to take this. Hold on, I need to get that on. Yes, I'm going to get that off of it. Okay, I just wanted to write those a little bit tighter. So what the rational root theorem says is if I take all the factors of P, the 6, divided by all the factors of Q, 2, and I write them out into a list, okay, this is my guessing and checking at its best, okay? If the roots are rational, they will be in this list. Notice there's 2, 4, 6, 8, 10, 12 possibilities, okay? Meaning what that plus or minus 1 means is it means if 1 is a root, okay, no x minus 1 is a factor. If negative 1's a root, that means x plus 1's a factor. And it's a ditto for the 2, okay, plus 2. And it goes all the way down the line until I get to these guys. These are the crazy looking ones. That's like 2x plus 1 or 2x minus 1 for my plus or minus a half. So if these are roots, then these are factors, okay? And how do I know which ones are? Guessing and checking. Start at 1, go to 2, go to 3, go to 6, go to, that's what I would always start with, the integer values, because let's face it, those fractions are a little bit harder to synthetically divide out, and then we're just going to guess and check, okay? So Beyonce and Ivy, each list possible rational roots for the polynomial equation they are given. Okay, explain why Ivy's incorrect with her work. Well, Beyonce over here, she's correct because she's taken P, here's my P, remember that's constants, factors of 10, so that's 1 times 10, 2 times 5, plus or minus of each, those are all my factors of 10, and 4 is 1 times 4 or 2 times 2, so if it's the same factor, I only listed the once, and then took all the p's divided by q's. So took the 1 and put it underneath 1, 2, 5, and 10 to get these, 1, 2, 5, and 10. And she took the 2 and put it underneath each one of these, 2, 2, 2, 2, and saw that 1 right here was repeated, so she didn't write it again, but there's a half, 5 over 2, that was a new one. And then the 10 over 2 was another 5, and then she put the 10 over the 4. Okay, well, what did Ivy do wrong? Ivy took factors of P. 1 times 15, 3 times 5. Okay, those are all the factors of P. Now, how about all my factors of 6? Well, what times 6? I needed a plus or minus 1 in here. 1 times 6 gives me 6. 2 times 3 gives me 6. So Ivy never put 1 underneath all these, so she's missing possible plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So, and because if you look at all these, there's pluses and minuses in all of them. Therefore, Ivy can be guessing and checking on hers, and there's 2, 4, 6, 8, 10, 12, 14, 16, 18. Actually, she had that one in there and that one in there. Sorry, I missed that. There's that one. There's that one. But she missed the 3 and the 15. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. She could guess and check 24 times. And you want to know what the really nice part about this is it might not even have rational roots. If the number is not a rational number, guess what? It's not in that list. Well, then you say, well, how the heck do we find them then, Mr. Kruger? Well, if you don't have graphing technology, you can't find it. Simple as that, okay? So we're going to hit out an example here. So we have complete each step to factor and solve x to the fourth plus x cubed minus 7x squared minus x plus 6, okay? Notice, we've got 5 terms here. There are 5 terms. And whenever we're trying to do this, I would always try to factor it first, but I honestly have no idea how to factor 5 terms, okay? So I'm going to find my p, and I'm going to divide it by q. Well, what is my p? My p is 6. My q is 1. So I'm going to take all the factors of 6. 1 times 6. 2 times 3. Those are all my factors of 6, but I need to make sure I'm taking positive and negatives of each one, okay? I don't know if they're positive or negative. Over my factors, only factors of 1, well, it's plus or minus 1. So that means I'm going to have to guess and check possible factors, or actually possible roots. This is a rational root theorem. This is possible roots of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. There's no 4 in there. That needs to be a 6. Getting all excited. Plus or minus 6. So there are 8 possibilities of rational roots to be here. Then what we're going to do is we are going to use synthetic division to find out which ones there are. So what I do is I always start with positive 1, and I will synthetically divide it out. And I'm going to say I got a coefficient of 1 on the fourth, 1 on the third, negative 7 on the x squared, negative 1 on the x, and a constant of 6. If 1 is a root, we know we will get a remainder of 0. If we do not get a remainder of 0, we know 1 is not a root, which would mean x minus 1 would not be a factor if I don't get a 0 remainder. So what we're going to do is we're going to drop it like it's hot and say 1 times 1 is 1. Add what's above it for 2 times 1 is 2. Add what's above it for a negative 5 times 1 is a negative 5 plus what's above it is a negative 6 times 1 is negative 6 plus what's above it. Sweet deal. 1 is a root. I just proves 1 is a root because we got a 0 remainder. So then the next direction says rewrite the polynomial as a product of its quotient and linear factor. Well, what that means is this root right here is a factor of x minus 1, and if I take that times by what's left over up here, which would be x cubed plus 2x squared minus 5x minus 6, we just factored that polynomial of 5 terms up here, right up here, that we did not know how to do. We just factored it using synthetic division in the rational root theorem, okay? Then it says, repeat steps A through C for the cubic expression. So that would be for this expression. Now, the first thing I would totally encourage you to do is take that x cubed plus 2x squared minus 5x minus 6 and try to factor that, because if it factors by grouping by taking your x squared out with an x plus 2, and here I'm going to take a negative 1 out, that's going to give me a 5x plus 6. If it did, well, it won't. It doesn't factor because those parentheses are not the same. Well, that means I start all over again, but now all I'm going to do is I'm going to start over with the cubic function again, because this This is already a linear factor. I need to try to break this down more. Well, the nice thing about this particular problem is now I'm going to do my P over Q business all over again. Okay? So notice it's 6. So I'm looking for all the same ones that I had before, because notice my P and my Q didn't change in this case. Sometimes it does, and sometimes that narrows things down. So now I'm going to use my plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and I'm going to try to synthetically divide out of this one. Now, I would encourage you to try what just came out again, positive 1, because remember we have things that are called bouncers, which means I could have the same root more than once. So I'm going to try to synthetically divide 1 out again, okay? And I'm going to have a 1 and a 2 and a -5 and a -6. Now, really, I never divide out, I never synthetically divide out positive 1 because there's a shortcut. Notice all these coefficients I had up here. Notice if I add them, 1 plus 1 plus -7 plus -1 plus 6. Notice those add up to 0. And if that's the case, this only works for positive 1. If that's the case, positive 1 will be a root, okay? Well, what's 1 plus 2 plus -5 plus -6? Does that equal 0? And the answer is big fat no. You know what that means? That means positive 1 won't work, so I'm going to cross my positive 1 off. And I'll usually write 1, 2, 3, 6 slash -1, -2, -3, -6, so I know that one's not going to work. What do? I move to the next one, which would be 2, and I try to synthetically divide it out, because if it works, I know I'm going to get a 0 there, okay? And how do I know which one to pick? You don't. You just guess and check. Everybody's favorite, 1. 1 times 2 is 2, plus what's above it is 4. Times 2 is 8, plus what's above it is 3. Times 2 is 6, plus what's above it is a 0. Well, I'll be. There is another factor, okay? It's a root, which means x minus 2 is a factor. Okay, so then what do? Well, we take what we started with down here and we say x minus 1, that was already a factor. Now I've got x minus 2, that's already a factor, and I'm left over with this, which is going to be x squared plus 4x plus 3. Now, if you continue to guess and check, I would really like to hit you in the back of the head with a stick, because this is a quadratic. It's not spelled really nice, Q-U-A, and you know how to find the roots of a quadratic, because if it doesn't factor, they are not rational, okay? And if they're not rational, then I would have to use the quadratic formula to find my roots if I did. Okay, so we're going to look. Does this factor anymore? Well, I would have an x times an x. Factors of 3, well, my signs both have to be plus. Factors of 3 are 3 and 1. That's it. Oh, look at there. And if I multiply that through, I get what's above it. So I have just completely factored my 4th degree polynomial on the top. Okay, so there we are. So what do we do with that? Well, we completely factored it. So if we're going to determine complete each step to factor and solve, we have factored it, now we need to solve it. Okay, and if I solve it, I know my roots will be x equals 1, x equals 2, x equals -3, and x equals -1 are my solutions or roots. I have solved it, okay? A little bit of work in some of these here, right? So hopefully, if you have some questions, reach out to us on the chat during either one of my class or Mr. Meyer's class. We'll be happy to help you out with it. If not, work on that, try on your own today, and we'll be back to expand a little bit tomorrow.